Hello everyone, this is Matteo from Software Design. A couple of years ago I wrote a few blog posts regarding FPGA and DevOps, in particular how to use Xilinx, AMD Vivado with Git, Jenkins and Docker. You can find the links in the description below. In this video series I'm going to update that content using Vivado in petalinux 2024.1. I will also replace Jenkins with Gitlab for continuous integration. With this video series, I want to show that it's not difficult nor expensive to get started with DevOps for FPGA development. Let's begin. First of all, why should you introduce DevOps in your FPGA development flow? During the development and support phases of a product containing FPGA, several bit streams are released containing new features, bug fixes, etc. Releases are more frequent during the development phase, as new features are added to the design, while the support phase can last from a couple of years for a consumer product to 5 or more years for an industrial product. In my career, I came across issues like the release bitstream was built using different source code tree from the one tagged for release. If the bitstream is built on developer's PC, then local changes might not have been saved in the source version control system, and the source code track for the release is different from the one used to build it. It works or builds on my PC. Releases should be built in an environment where OS, libraries and tools are under control, and it is easy to recreate and build the environment. The developer's PC might break, or new OS, libraries and tools are installed, and the build tools might not work anymore. This is particularly important when the support period is long, of 5 or more years for industrial application, automotive and defense. The only engineer that can create a release is on a holiday or a business trip or simply left the company. When the release process is not automated, it is prone to error, even if well documented. It makes it more difficult to scale up the development team. It is not possible to replicate the environment or get the source code that we use to build a particular version that has a bug. If a bug has been found, it should be possible to easily recreate the environment where the bug can be replicated and debugged. Sometimes the suggestion use the latest version might seem to fix the problem, but it could just hide the issue. DevOps is a set of practices that combine software development, or in this case FPGA development, with IT operations. The objective of this video series is to share tips and tricks on how to apply DevOps tools and techniques like source version control, continuous integration testing, and release automation to FPGA development. The same tools and techniques can be applied to microcontroller firmware development, or in general when an artifact, binary, is created from source code using a tool like a compiler. The goals of DevOps include not only solving issues described earlier, but also increased development frequency, faster time to market, lower failure rate on new releases, and shorter lead time between fixes. Gitlab is a complete platform for software, or in this case FPGA development. It provides source version control, code review, continuous integration, issue tracking, and way more. There are various versions, some are free, some are not. You can use Gitlab hosted in the cloud, or you can host Gitlab yourself. Full disclaimer, this video is not sponsored by Gitlab. I have used it in the past and had a good experience with it. In the next video, I'm going to show you how to use version control for Vivado and petalinux projects. If you enjoyed the video, please leave a comment, click on the like button and subscribe to the channel.